Alright, for this next problem from chapter 4, we need to think about polynomials in terms of their building blocks. We have a cubic function f of x that has roots at 1, -3, and 2. And we also have a y-intercept. Now when I started this off I said building blocks. Well, the building blocks of every polynomial are factors. And this taps into what's called factorization theorem. That says that every polynomial is a, which is that leading stretching coefficient, times a list of factors. In this case, since it's a cubic, there are only 3 factors. And I put minuses because minuses are easy to switch to plus, and it's always x minus root. So if there are 3 roots, then we would plug the 3 roots into here. So we have 3 roots. X minus 1, x minus 2, or x minus -3, which would give us x plus 3, and x minus 2. These are the building blocks of this polynomial. Now, just to check, if you plug in 1, this becomes 0. Multiply everything together, it becomes 0. That means it's a root. -3 means this becomes 0, which makes it all 0, which means it's a root. And 2 makes this 0, so it's all a root. So it's all 0, so it's a root. The question is, what's a? Now, some of you are going to go to great lengths to expand on this. I'm okay just leaving it like this. F of 0 is going to equal a times 0 minus 1 times 0 plus 3 times 0 minus 2. Now, that gives us the advantage of not having to multiply things until we have to. So -1 times 3 times -2 is going to give me positive 6. So f of 0 is going to equal 6a, which we get is -12. Solve for a by dividing by 6. A is equal to -2. So I then know that my polynomial is f of x equals -2 times x minus 1 times x plus 3 times x minus 2. And again, leaving it in factored form is entirely okay. You don't have to expand it if you're not called to.